Okay, so we're going to talk about factoring trinomials. And I'm going to show you two different methods to do this. The first method, let's grab a trinomial. Let's try one right here. Well, before we factor it, let's expand one out. X plus 3 times x plus 5. Let's do a FOIL on this thing. Because factoring is the reverse of doing a FOIL. So let's FOIL this out, and then we can kind of do it backwards. X times x is x squared. X times 5, 5x, right? The outside. The inside plus 3x. And then the last term times the last term plus 15. So we combined them. Now, what we want to do is we're going to start out with this trinomial right here. And we want to bring it back to a factored form. So we can tell that, well, obviously, the first two terms were x's. X times x gave us the x squared, right? So this was an x and an x. And we knew the two outside numbers. We combined the outside, this outside number and this outside number, the last number, I should say, the two last numbers gave us the 15. So looking at this one, if we didn't have all this above it, we could tell this would be probably a 15 would be, well, it could be 1 times 15, but it's probably 3 times 5. So we could kind of tell that. And then we could see that these two numbers could add up to 8 if we did the outside and the inside. They would add up to 8. So if I wrote this outside right here and the inside right here, they would have to equal the middle term, 8x. So these last two numbers multiply to give me the last term, but they add up to give me the middle term. And they would both have to be positive to give me a positive 8. And then I do something called a safety check. I check if a positive times a positive is a positive 15. So I can work the kind of the problem by working it kind of backwards. So what I have here is the answer, and I'm trying to figure out what was the original problem that gave me that answer. So that one not too hard. And most of them we're going to do today are pretty easy, but then we're going to get into some more difficult ones. Let's try this one. Here's one. X squared plus 9x plus 8. Okay. So we know this is going to be x and x. Okay. And then we look at the last number, this 8. So we might think, okay, I'm going to do it wrong on purpose. This might be 4 times 2 because that's a common number that makes 8. But if we go to the outside, 2x, and the inside, 4x, we see that adds up to 6x, but I need a 9x. So this combination is not going to work, 4 and 2. So now I'm going to try another combination, and this way we call this sometimes trial and error. What else could we use for 8 to get an 8 here? Or to get an 8, I should say right there. 1 times 8, huh? 1 times 8 could give me 8. This would be 8x and 1x. And if we add them together, we get 9x, right? So this would have to be a plus to get a positive 9x. Then we do a safety check. Is a positive times a positive a positive? Yes. So I've got my combination. Okay. So that's kind of the idea behind it. We're trying different combinations that will give us the answer that we want. Let's see if I can find another one here that's not too hard. Let's suppose I try this one. And then we'll do some variations on this. So again, I might be thinking x and x, and I'm just going to put this in pencil. I might be thinking 6 and 6, because 6 times 6 is 36. That's a pretty common way to get 36. But if I do the outside 6x and the inside 6x, you see they only add up to 12x. I don't get that combination. So I have to think of another combination that will give me this. So now I think of what's another combination that gives me 36, 4 and 9. So let's try 4 and 9. So this would give me 9x plus positive, maybe plus 4x, and that would give me a positive 13x. You see? So these two look like that would work. We double check it by multiplying. Positive 4 times positive 9 is positive 36. So if this last term is a plus sign, that means both of these signs are going to be the same. Now, what if this was, instead of a positive, this was a negative right there? Then the outside would have to be a negative 9, and the inside would have to be a negative 9 to give me a negative 13. Both of these would be negative, but they still would multiply to give me a positive 36. They would add up to a negative 13, but multiply to give me a positive 36. So that's kind of the idea behind it. Let me see if I can get another one here. Let me try it here. Let me, if I had this one, let me give you a little bit more difficult one. X squared minus 13x minus 48. Okay. So what are you thinking about on 48? Maybe you're thinking 6 times 8. 6 times 8 is 48. Okay, I'm going to write it down. X and X, 6 times 8. Outside, 8x. Inside, 6x. But there's no way that's going to give me a negative 13x, is it? I mean, if they were both negative, but then a negative times a negative is not going to give me a negative 48. Any other ideas? What else could give me 48? What about 2 times 24? 2 times 24 is 48. Outside, inside. That could have given me a negative 13x? No. So sometimes we might be surprised that 48, we're used to 6 times 8 is 48, but it isn't always true. So let's take our calculator. Let's take 48 and we divide it by 2. Now, what about these factors? Notice that the last term is negative. That means that both signs have to be different. We're going to actually, here we added because they were both the same, but when you see a minus sign there on the last term, that means we're going to subtract these terms. We're not even going to add them together. We're going to have to subtract them. Even if we subtracted, that wouldn't work. So 24 take away 2 is 22. That's not going to work. So let's take this 48 now, and we tried dividing it by 4. That was, I mean, that gave me 4 into 48. I could use 4 times 12. 12 take away 4 is 8. That's not going to work. So what if I took 48 and I divided it by 3? You think 3 are going to 48? Let's find out. 16 times. What's 16 minus 3? 13, huh? 13. So let's write this problem down again. Put it over here. Okay, so I need a 13. So this would be X and X. So these numbers that I choose, I can't just pick any two numbers I want and they work. I've got to pick out the correct two numbers, which would be 3 and 16. Let's do the outside, 16x, the inside, 3x, and I need a negative 13x. How can I get that? Well, this would have to be a negative 16 and a positive 3. Now, if that's the case, if this 3 is positive and this 16 is negative, would that give me a negative 48? Yes. See, a positive times a negative is a negative. So these have to have opposite signs. That's what this is saying right here. They have to have opposite signs. And they have to, when you subtract, when you get through subtracting, they have to equal that middle term. Now, another way I do this is I do a method called the X method, the X box. Okay, maybe you were shown this. I don't know if you have. I bought this from an Australian mathematician. It cost me $10 to get this method. I had to buy this. I got like a biography of 4 mathematicians and 4 jokes that I cannot tell. Okay, so anyhow, it was such a deal. I couldn't resist it. But I saw this little method and it's pretty cool. I put the negative 48 up here and I put the negative 13 down here. And these two numbers have to equal the middle term either by adding or subtracting, and they have to multiply to give me the last term. So we figured out that they would be X and X, 3 and 16. And now I can see that a negative 16 plus 3 is a negative 13. And a negative 16 times 3 is a negative 48. So I can see the whole thing right there. So this has to be a positive 3 and a negative 16. There's only one combination that's going to work on this. This combination does not work. This combination does not work. We could put in signs in here, but that's not going to work. There's only one combination that will unlock this trinomial, and that's what you're trying to find. Now, what I did is in your thing, I kind of cheated here. I have the factors of 48 written down here, and I'm giving you this sheet for absolutely free. And this sheet has all the factorization, all the combinations that make up various things, like 40, 1 times 40, 2 times 20, 4 times 10, 5 times 8. These are all the combinations. Look at the combinations that make up 36. 1 times 36, 2 times 18, something we don't think of, 3 times 12, 4 times 9, 6 times 6. And then on the back side, it goes all the way up to 100. So I have this sheet for you. It's in your module. You can download it, and it will come in very handy when you're trying to factor something like 84, and there's all these combinations. You probably didn't even think there would be that many combinations. 83, pretty easy. There's only one. 84, a ton of them. Look at this one for 85. Who would think of 5 times 17? You know, not a very common, but they only go up to 100. So if you have a problem that goes beyond 100, we've got some problems, big problems in River City. So let's see if I can give you another problem and see if we can do it. Let's try an easy one here before we get into that. Well, let's try this one. X squared plus 17x minus 110. You see, this one's a little bit hard too, because even my sheet, as good as it is, only goes up to 100. I don't have 110. So I'm going to let the calculator help me. First of all, I see this has a minus sign. Let's switch to our little X box. Negative 110 and 17. So I know that these have to have opposite signs. The bigger number has to have a plus and the smaller number a minus. But I don't know what they are. You know, So I'm going to look for the factors of 110. And so the way I have my calculator help me is, let's clear this out. Let's turn it on. I'm going to take 110 and I'm going to divide it by 2. 55 take away 2 is 53. That's not going to work. Let's try 110 divided by 3. It's not going to work because this is a decimal. I need a whole number. So that's not going to work at all. 110 divided by 4. Again, that's a decimal. That's not going to help. How about 110 divided by 5? 22. 22 plus 5 is 27. Not good. 22 take away 5 is 17. But this is a plus 17. Now let's see how we can get that. Let's put the 5 here into 22. If the 22 were positive and the 5 was negative, would that give me a positive 17? Yes. Is negative 5 times 22 a negative 10? 110? Yes. So this helps me kind of get the numbers going. I have to use my brain to kind of get the signs going a little bit here. So now I can write this down as x times x. First times first is going to be x squared. And then the 110, let's see, a negative 5 plus 22. That's my positive 17. And then if I multiply them, there's my negative 110. So remember, if this is a minus here, it means we're subtracting these numbers. If it's a plus here, it means we're adding them, but they both might be negative, you know. We're going to add them together because a negative times a negative is a positive. So let's try another one of those, see if we can do it. Maybe not quite as hard. Let's see if I can find one in your assignment here. Let's see. How about this one? This one's fairly easy. Okay. I need a positive 21, but a negative 10 here. This is going to be y, this is going to be y. Okay, think of 21, 3 times 7. But I need a negative 10. So these both would have to be negative to give me the negative 10. Negative 3, negative 7, negative 10. But would I multiply to give me a positive 21? Negative 3 times negative 7 is a positive 21. So this is negative 3, and this is negative 7. And now I factored it out. Now, how do I know if I'm correct? I can go back and I can do a FOIL. Y squared, outside, inside, last term times last term. So if I want to really double check it, I could do the FOIL. But I've already got it kind of written out right there. But if I want to, double check it, I can do a FOIL. Okay, so here's your factorization. This is just a check right here, checking if it's done correctly. All right, so that's kind of the idea of factoring. Now, don't think that factoring is going to be this kind of factoring is going to be super easy, because next week, we're going to start putting a number in front of here, and that's going to make it all real complicated. And that's why we want to do it kind of by this Xbox method. Because if you do it the other way, sometimes there's 36 different combinations that may work on this problem, but only one out of those 36 is going to work. Right now, there might be only 6 combinations, but later on, there's tons of combinations, depending on especially a problem like this. So if you add a number in front of this x squared, it really complicates things. So if we do it by this method, and I'll show you a little variation on it, we can do it fairly simple without racking our brain. Okay, let's try this one. Holy moly, what are we talking about here? Okay, well, let's try it. We want them to multiply to 1 over 25. We put that on the top. That's what these are going to multiply to. And we put the 2/5 here because we want them to add or subtract to 2/5. Well, we know 5 times 5 is 25, and 1 times 1 is 1. So this would be 1/5 times 1/5. That would work. But what about adding them? When we add them up, we keep the common denominator, right? 5, we just add the numerators. So that would work, except that these need, what? They have to have a p. So this is your p, and this is going to be a positive 1/5 and another positive 1/5. Sometimes we condense the answer to just p plus 1/5 squared because both of these parentheses are the same. So when we square something, we multiply the same thing by the same thing, But that would be our factorization. So we can still use this little technique to help us. All right, let me do something that might be a little bit harder. Let's try this one. Okay, so to do this particular problem, we first want them in descending order. Okay, so we're going to rearrange these terms. We're going to keep the same signs. All we're going to do is put our a squared first, negative a squared, keep the sign with it, minus 10a plus 25. But we want to factor, we want our a squared term. This is our leading coefficient. We want the leading coefficient term to have a positive value to it. So we're going to factor out a -1 out of all these. And that's going to make this positive inside here. This is going to be a positive 10a because it'll be just the opposite sign. And this will be a -24. See? So we're going to change the signs. We're factoring out a negative. It becomes positive, becomes positive, becomes negative. Taking out a -1 changes all the signs. Change, change, change. Okay, now this is what we're going to try to factor down. Obviously, this is going to be a and a. So let's do our little x thing here, -24 and a positive 10. Okay, so when you say 24, you're kind of thinking to yourself 6 times 4. Okay, would that work? Okay, I need a positive 10, but then these would both be positive, but that would give me a -24. You see, so I need a -24. So I'm going to go back to my cheat sheet. I'm going to look up 24 here. And I see there's other combinations. There could be 4 and 6. There could be 3 and 8. But remember, I'm going to be subtracting here. So I'm thinking to myself, 6 take away 4 is 2. Now I need a 10. 8 take away 3 is 5. I need a 10. 12 take away 2 is 10. That's what I need. I need a 12 and a 2. It doesn't matter which one you put down first. 12 and 2. This is the combination I'm looking for. And I need this to come out positive, so I need a positive 12 take away 2. 12 take away 2 is a positive 10, and then a positive 12 times a -2, one negative, and the whole thing is negative. So this is going to be a plus 12 and a minus 2. And then I still want to bring down this -1. And that's the complete factorization. So sometimes I have to take out a common factor, such as a -1, to make all these terms. I want this leading term to always be positive. And once that's even positive, it's still kind of hard because in our head, we might be thinking 6 times 4, 6 and 4 is 10. But that's not always the case. If you put this down here, you're going to see 12 minus 2 is 10. 12 times minus 2, or 12 times negative 2 is negative 24. You're going to get your combination. There's only one combination that works on this problem, and it isn't 6 and 4. It isn't 8 and 3. It isn't 24 and 1. There's only one combination that's going to work. So we want to try it. Okay, here's another one. This time, so we want these in descending order, which this one is. But before we jump into factoring, and sometimes when we get into this, we might have a number in front. We always see if there's a common factor you can pull out. Okay. We need a 1 when we multiply. We need a negative 2 when we add. So 1 times 1 is 1. 1 plus 1 is 2, but I need a negative 2. So this would have to be a negative 1 and a negative 1. A negative 1 and a negative 1 will give me a negative 2, and they will multiply to give me a positive 1. So that's why this kind of helps, to kind of line out your work. I think it was worth $10. Okay, so now I got my WW, I got my minus 1, and I got my minus 1. You see? And I can double check it. Do these add up to negative 2? Do they multiply to give me a positive 1? And I project down this 3. Don't lose that 3. Okay, later on you might throw it away, but for the time being, we want to kind of keep it. Okay. So I'm going to try one more here. See, what if we had multiple variables? How about this one? These always would, I remember when I was taking algebra the first time, and I'd see a problem like this and go, oh, grunge, this one looks pretty tough. So what's happening here is we got double variables going on. We got x's and y's. So x times x, give me the x squared. And y times y will give me the y squared. So I'm just going to worry about the numbers right now. Not y squares and x y's and all that. I got to write this down with the sign. Make sure you write the sign with it. And same thing here. Okay. 48. Where's 48? Right here. 6 and 8. 8 take away 6, 2. Probably 12 take away 4, 8. Now 24 take away 2. Because I'm subtracting. That's why I got the negative here. It's telling me subtract. So I'm pretty sure it's 6 and 8. Which one gets the negative sign? The bigger number is going to get the negative, right? Negative 8 plus 6, negative 2, multiply, negative 48. Okay, so let's fill in the signs. Let's put those numbers in. Plus 6 in front of the y, minus 8 in front of the y. Let's see if that would work. If we did the outside, see, you get a negative 8xy. Inside 6xy, negative 2xy. So this is the combination that's going to work. So even though these had x's and y's, don't get panicky. Put those down first. Concentrate on your numbers then. So it's pretty interesting, huh? That you can do all these things. And remember, very important that your lead coefficient should be positive. You want to factor out that negative 1. Don't try to do one negative and one positive, and you're going to go crazy, and then it's not going to look right anyhow. So you want to make sure you take that out and try these problems here. They're not going to be, some will be hard. And make sure you download this, because these problems are not going to be super hard, but when you will get into some where this worksheet will come in very handy. A lot of times it won't be the most obvious one, like 6 times 9. It's going to be something like 3 times 18 or something like that. Oops, so you can't see it. 3 times 18 or something like that. So, and if you want to make one that goes up to 200, well, that's up to you, but at least you have that much to help you. Okay, do you have any questions? Very exciting here. Let's see. Let me try something here.